To graph the reciprocal trig functions, you need to remember three things. First, anything that is a zero of the normal trig function becomes an asymptote of the reciprocal function. Asymptotes of the normal trig functions become zeros for the reciprocal, and if it's a 1 for the normal trig function, it is also a 1 for the reciprocal trig function. So if we start with cosecant, which is the reciprocal of sine, if we start with the normal sine curve, any zeros become asymptotes. There's a 0 here, so we're going to have an asymptote here. This is a 0, so we're going to have an asymptote here. And this is 0, so we have an asymptote here. There are no asymptotes in the sine function, which means there are no zeros for the cosecant function. And it has a value of 1 here and a value of -1 here. So the 1 is going to stay a 1, the -1 is going to stay a -1. And then we're going to curve up toward the asymptotes from the 1. And from the -1, we curve down. Secant is the reciprocal of cosine. So again, the zeros become asymptotes. There are no asymptotes for the cosine curve, so there are no zeros for secant. 1 stays 1, -1 stays -1, the 1 stays 1, and the 1's curve up, and the -1's curve down. All right, for the cotangent, zeros become asymptotes. So we have an asymptote here. And here. And here. Where there was an asymptote, we end up with a 0 for the function. So this is going to be 0, this is going to be 0, this is going to be 0, and this is going to be 0. 1's stay 1, so this is going to be 1, 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 the -1's stay -1's. And then we're going to draw the curve. 0 curves up through the 1, up at the asymptote, down to the -1, curving down to the asymptote. And that is the graph for the cotangent curve.